Okay, can we restart? So Tarja,
Yes, Tarja
Tarja,
Kallio, and I'm pleased to give you some clarification of the content of Planck's constant related to Tuomo's researches on his model. And I guess we have already had quite a long morning, but hopefully you can still follow me, because I hope this is a little bit easier stuff than what we have been listening until now. So, clarifying the content of Planck's constant is the title, and I will start by stating what I think are the benefits of these clarifications. So we know that historically Planck's quantum was the starting point for quantum mechanics and also for modern physics, as it didn't fit to the context of classical physics. With this clarification, the transition from classical to modern physics, it becomes less dramatic, not that big a paradigm change, because we say that this clarification provides a solid bridge from classical to quantum physics. So classical physics, it was dealing with particles and waves. Matter was considered to consist of particles, and radiation was waves, so it was either or. Until these categories got mixed to quite strange kind of wave-particle dualism, which actually also can be solved with this clarification. And this clarification also refines the concept of mass and particles and leads to an improved understanding of reality, which I think really means a quite a revolutionary change, not only for physics but for humanity, giving better understanding in what kind of reality we are living in. So these are quite promises. Let's see if we can confirm these within 30 minutes. And where does this come from? As I already told, and Tuomo also presented himself, that he was able to derive the Planck's constant from Maxwell's equations, and because Planck just postulated this constant based on experimental results on black body radiation, it is already confirmed that there is a bridge from classical to quantum physics, from Maxwell equations to Planck's equation. And where does this knowledge then lead? If we know the exact content of Planck's constant, we can grasp the nature of quantum and the reality behind. It becomes much easier to understand what is going on. And we can see that it was the opacity of the constant that prevented making sense of the wave-particle duality and quantum mechanics. The interpretation was too difficult. And how did Suntola find the more precise content of the quantum? As he already told, it is based on his he came to the idea based on his new theory. It was visible that somehow she had to be hidden in this age, and Tuomo started to investigate the possibility. And thought that the smallest amount of energy, it should be the energy emitted by one electron when oscillating once in an antenna. And calculating this energy from Maxwell equations, he got this, where you can then find the constant h, which contains many familiar other constants, E, I don't know, remember in English this, it is this, but you probably all know physics so well that you know these constants and understand them immediately. And now, by taking C out of this H, we get intrinsic Planck's constant, and we can substitute it to this Planck's equation and get it into, now I'm sorry, into this form, which actually reveals a connection between wavelength and mass. Because the energy of this radiation quantum can be written to be equal with the rest energy of mass. So these equations hold when m is h0 per lambda. And this result means that mass and wavelength, they should not be taken as independent quantities. They are inversely proportional to each other, and they can be expressed in terms of each other. So we can see that all waves contain certain amount of mass, and any amount of mass can be expressed as a wave. So the second benefit is confirmed. Particles containing mass can be described as waves and vice versa. There is no incompatibility between these entities. The classical idea of particles and waves as separate categories, it can be totally overthrown. And de Broglie's dream is thus fulfilled. De Broglie said that I was guided by the aim to perform a real physical synthesis valid for all particles of the coexistence of wave and the corpuscular aspects. So now it is really done. Even if we know that de Broglie got Nobel Prize for his idea of combining waves and particles, but he did not succeed completely. Why de Broglie and quantum mechanics also failed to completely unify the particle and wave aspects? De Broglie presented equations for his matter waves, which are presented there. And these equations did not describe events accurately because these wave packets, they decay rapidly over time. And also in collisions, they just pass through each other. So these equations, they only apply to photons whose momentum is m times c. And we can see that Sundalas equations, they are obtained from those above when h is replaced by h0c, and the momentum for all the particles is assumed to be m times c. So the same equations we already got. And now we can see, compared to the Broglie's equations where there is this momentum which contains v, these Suntolas equations, the wavelength of the particles no longer depends on the speed of light. And we can see that this equation for wavelength, it is a more general form of the Compton wavelength, which Arthur Compton presented in 1923 for photon scattering. Now it applies also for material particles. And we can conclude that Broglie failed to find the proper connection because he did not realize that C is included in H, and he also illegally or too hastily tried to replace mc with mv, just because material particles travel at speed v. But Suntola found a legitimate role for both the velocities, which should never be mixed. He noticed how these both speeds are related to each other. And now we can move into more philosophical questions related to this new connection between wavelength and mass. We can ask, is there a plausible interpretation for these new mass waves? Are the particles real, or are the waves real, or is reality consisting of something else? The big questions that has been asked when trying to interpret quantum physics. Because the core of this interpretations, discussions, it is the problem concerning the perceptual understanding of the microworld, the ontology, the nature of ultimate entities, can we reach them or not? And as we know, Niels Bohr emphasized complementarity, saying that the concept of waves and particles, they are both needed, they are necessary, but not able to reach the deeper nature of reality. And we can ask, if he had known this new equation, would he have accepted this abstract mass wave to be the basis of reality? And David Bohm, he considered that both particles and waves are real, whereas Schrödinger, for example, sought to describe everything as waves, which goal also now can be realizable. So maybe we are now getting more understanding about this issue based on this new relation and equations. What should we now say about the nature of smallest entities? And it seems that all these interpreters, they were on the right track. Our concepts do not properly capture the dual nature of mass waves, but nevertheless, we can consider both the particles and the waves to be real. And also we can see that there is something intangible that is nevertheless real. It may be that waves, particles, and all possibilities arise from one abstract and intangible basis. As Suntola has shown, that the particles can be understood as closed mass wave resonators whose momentum is zero when they are at rest. It means that in this their rest frame in space, because in du itself the momentum is directed to the fourth dimension, but we don't need to take that into consideration here. We just can think that momentum is zero when the particle is resonator is at rest. When they move, there is a different kind of Doppler shift related to this wave, which is moving to the same direction than the particle, and the backward moving quantum wave, it gives a different kind of Doppler shift. And a new sum wave appears, which is moving at the speed v. So we can combine the differences on the there appears different kind of waves moving to opposite directions, and of course they are then combined, and we get a new sum wave which is just moving on the same speed v, and the particle is known to move. And now it is claimed that these new types of de Broglie waves could be responsible for many quantum effects, explaining, for example, the double slit experiment. So this is just very briefly here. We come, if we have time, we can have a little more close look on that. But just to move on to the more interpretation of things, we can think that the existence of waves and particles seems to result from different types of mass waves. These new things which are somehow related, the mass and wave aspect together. And there are trapped mass waves which are forming a closed pattern. They are observed as material particles. And then all over there are these untrapped mass waves which completely fill up the space. And they are evolving related to what kind of circumstances we are in. And we can relate this to the manifestation of possibilities. And these new waves, they are something much more real than just mathematical tool for calculating probabilities as in standard quantum mechanics. They contain mass, they have real effects, even if we are not able to see them. We just see those trapped waves. But nevertheless, those untrapped also are something very real, which has effects on what is going on in reality. So we can say that these mass waves or energy-sized mass could be seen as the basis of all manifestation, but the mass in itself, it is something that we can never touch. It is only when it is energized, so then it becomes something real, but nevertheless, the mass that is behind, it is something that is really eternal. It stays even if energy such changes and may vanish. So whether this is that or not, the benefit 3 is confirmed. Certainly this new relation refines the concept of mass and particles. So what about understanding reality? We know that this idea of removing C out of H originated from DU theory, but the theory itself, it is not needed for its implementation. So the procedure, it fits within the boundaries of normal science and nevertheless reveals completely new things about mass and reality. But if we move on and accept the simple and credible premises on which DU is built, all the phenomena examined within quantum theory, relativity theory, and cosmology, they can be expressed in a single framework, whose development is completely by law, but not deterministic. And in this kind of evolving monistic system, there is a natural location for humans and their influence, and the invisible layers within the system, they would allow to bridge the gap between humanities and natural sciences, eventually reconciling mind and matter. So it is possible in this kind of framework. There is no duality between mind and matter, which has been the problem for philosophers to understand how human consciousness, mind, is related to this world, because there has not been enough space for it and freedom. But in this DU framework, it naturally allows this kind of possibilities for philosophers to build up better theories to understand human consciousness and mental phenomena. So I think this benefit 4 is confirmed. Clarification of Planck's constant leads to more or less improved understanding of reality. And so I can thank you for following these my slides. And now there is a couple of Tuomas slides if we still have time.
Yeah, we just got a
Yes.
few minutes. Yeah, no problem. Maybe a delayed
Yes,
little bit.
they just clarify these things more mathematical manner. And first from quantum wavelength to the de Broglie wavelength. And here we have this sketch of what may happen when particles pass move a double slit. We have here the particle, quantum resonator, quantum mass wave resonator or standing wave. And at rest, and its rest frame, its momentum is 0. So, and then here when it moves, we can see how the wavelength of the front wave decreases and the wavelength of back wave increases. So this new de Broglie wave or momentum wave is born. Here are also the equations depending on the velocity of the particle, of course, and the net momentum equations in the rest frame. And then when this is put to double slit, it's just we get the results on the green screen. And of course this has not been analyzed in detail, but it is something like that we can assume to happen. Now it is these de Broglie waves that pass the slit and they create the interference pattern at the screen. They are wide enough to go through those both splits, so there is no problem for that. And also the interference, it is just a normal pattern. And it is actually the absorption of the momentum that is detected, not the trapped quantum waves or the particles themselves. So it is the momentum only that is received, not the wavelength itself also. So one has to analyze carefully what we actually observe in this slit. And I think in those discussions with anyway philosophers read about this double split experiment, the analysis is not at all detailed enough. So what is observed and how? So it is also, of course, one of the reasons why this discussion has not moved on. Anyway, this model gives something new to think what might be going on and could clarify issues in that sense. And then also, Tuomo has calculated the principal energy states for hydrogen atom. So he doesn't need any Schrödinger equation to find these discrete quantum states in hydrogen atom. They can be just calculated as the minimum points of the energy of the resonance condition of the momentum wave or this de Broglie wave. Just from the energy inside the atom and then the resonance condition, and you can see that the same quantum states can be found, and also that we can see that they are continuous curves even if the minimum points are where the electrons actually are found. But there is no mystery of somehow that only in between the states the electron can't be anywhere, which we sometimes are discussing in interpreting quantum physics, try to understand how impossible it is that it is nowhere, but it maybe does not need to be that mysterious at all. And with this new way of looking at things, this mass waves, many other problems associated to quantum interpretation states just simply disappear. The whole concept of quantum actually, it seems to be reducible to the wavelength. Wavelength is indivisible, and this indivisibility gives a natural explanation why arbitrarily small amounts of energy or radiation quanta can't be generated Also, Heisenberg's quantum uncertainty principle is related to the perception of only entire wavelengths. And also the emission and absorption of radiation, it always just occurs in whole wavelengths. So, in a way, events, they can only happen when the wavelengths meet. So, Just yeah, okay. So this is more detailed. I didn't remember to press the button to get this final. And so this was the last slide. Thank you for your attention and
thank you very much. Good. Any questions? Yes, please.
Yes, I'm trying to understand what the model of a particle is here. It's a mass wave resonance.
yes.
So do we imagine a mass field which is confined to field, or is this an electromagnetic field?
Well, of course, I'm a philosopher and mathematical matters are not so obvious for me. And Tuomo is who has been just calculating these things. But I believe that when someone who really is dealing with these calculations and might find quite interesting results if studying this more carefully, trying to find out what comes out of
I can appreciate there is some very interesting stuff to be done in relation to these ideas.
No.
But I was just trying to understand what the mass wave resonator is, and what's the difference is. What kind of field is it which is resonating in there?
That comes probably from this antenna theory, but I'm not familiar with that. But you can ask Tuomo about this.
I guess I just didn't follow it.
Yes.
And then the distinction between the inside waves, the resonating waves, and the untrapped waves.
Yes.
Where do they come from? And one last question, perhaps, is does this model of a particle enable you to describe all the different sorts of particles that exist, that are known to exist? I mean, what makes them different?
Yes. Actually, we have in Finland also a physicist called Ari Lehto, who has been dealing with particle physics and probably by his theory, these questions could also be understood better, and we have had this society for this Physics Foundation Society now discussed in 20 years there, and this is one of the relations of this Ari Lehto's theory, these particles to Tuomo's theory. It is something that seems very promising, but it has not been also developed to the end, so maybe sometime if we get more interested people to the team. So
I was wondering, you've got these figures for the energy of the particle. So is there some energy-time uncertainty relation going on, or is that something you avoid in this theory?
Yeah, I can't tell. I don't know. But maybe Tuomo can comment something for this. Is there some energy-time relation, like?
Because in the usual quantum theory, then there's an uncertainty relation between time and energy. But it looked like on the slide you had exact energies for
Yes,
particles.
yeah.
So does that mean you have infinite uncertainty in time? Or
It was a nice surprise for me to find those hydrogen curves, because of my background is in electron physics and semiconductors, where we have energy bands. So that now we have energy bands, and the quantum sets are just the minimum of each energy curve.
so the idea is somehow the Heisenberg uncertainty principle has dropped out.
That's a very interesting question. As soon as you use H0, remove C from Heisenberg, from Planck constant, then you can also write the Heisenberg uncertainty principle equation in form which tells that you can only find the location or mass within the wavelength distance. So it tells that we can get better accuracy than the wavelength if you don't know the phase.
I see. So you can calculate the wavelength precisely, but you can't know within the bounds which one you're in.
Any other questions? Yes, I'd like to ask a question. Sorry.
Have you basically rejected Born interpretation in this? Let me explain what I mean by that. Quantum mechanics is statistical theory, and it's based on the idea that the waves actually express the statistical nature of quantum mechanics. And excuse me. And so therefore the waves are not real. What they do is they express, or they fit the probability curves that you obtain from the results. So like when you show the two-slit experiments or whatever, then what they're doing is saying, if you look at the probability of where you would find a particle, this is the curve you would get, and it seems to match the idea of the statistical nature being a wave. Now, so the quantum mechanics as it stands would not accept this.
That's right. But it is just because we are now able to make this H to put it to take the C out of that, then we
I
get.
don't understand how you would do that, to be honest with you. I still don't grasp how you would. If H is a constant, you can't change it.
Well,
so you can't take something out of it. So in other words, you either got to change your notion of what H is, or what, I don't know. Can I just finish off by saying that if you're going to promote this idea, and I'm not suggesting it's right or wrong or whatever, is that you're going to take on. I mean, because don't forget, we moved on from Schrodinger. I mean, now, of course, if you have the whole Feynman stuff, all right. I mean, if you look at the proton, for example, and when you look at the model which we have for the proton, which is, three valence quarks and the quark C, right? The latest results from the LHC seems to show that the quark, when I started particle physics, it was just, were there three particles, were there three quarks, did quarks come in, and did they exist at all, and did they, did the proton have three valence quarks within them? Now, the latest results from the LHC seem to show that, in fact, the valence quarks play quite a small role in the content of a proton and neutron. In fact, it's the quark C which is actually making the major contribution. So the things have moved on, and you would have to somehow take that whole concept on by coming out with this, and that's how I would caution you.
So of course the claim here is that this quantum, it can be this age, it can be divided. You can take the C out of there, and it comes from this antenna theory that the smallest amount of energy, it is the one that is emitted when one electron is oscillating once in antenna. And from this assumption, you can then derive from Maxwell equations this energy, which is this constant times F, and when you then take from this
Maxwell's equations, though, isn't it? That is from the Broglie's interpretation. E equals HF is nothing to do with that.
well, but this was this H. It was somehow it was the starting point for whole quantum mechanics, that it was found by Planck, and it is all just coming out of this. It has been somehow, if there is in this basic constant, if it is not accurate enough, as accurate as it could be, that's why we got to this confused situation. We couldn't understand what is going on. Now it seems that it can be presented much more clearly if we really can state that Planck's quantum, it contains H and it can be reduced to more simple form, then maybe all these mysteries would be gone. We can understand things much more clearly, and that is that's why I already, when I first heard about this theory, I got some idea that mass can be understood much more clearly, and also there is a possibility to introduce enough space for humans in this kind of framework, and that's why I got interested and have been following this, and I really believe that it is worth studying much more closely. And this conference is in that sense very interesting and important, that really there are many competent scientists who can understand these things. We have been trying in the Finnish Society for Natural Philosophy to introduce this theory, but because academic physicists in Finland, they have not been so interested in this, and that's why we have not got enough response.
Now that we've discovered the Higgs, how we deal with mass is becoming much more. What's the word for it? We're starting to understand it more, but there are problems to deal with that. But that would not be in this. That would not be in this kind of scenario at all.
Yeah, we don't know, but that's why we are here to discuss. But I guess now it is time for lunch. So
Yeah, I think I want to interrupt everybody. Thank you again for your talk, and thank you to everybody who spoke this morning.